Hey guys, welcome back to the channel. I'm very blessed and grateful to be able to sit down right now with Jude Nelson. He is the lead developer at Blockstack, and honestly, I'm just grateful for the opportunity to sit down and talk about Blockstack, talk about what Jude thinks is important in the space right now, what they're working on over at Blockstack, and really what's going on here at CESC. So Jude, thank you so much for taking the time today, sir.
My
Highly
pleasure.
appreciate it. Listen, so for the people who are watching who aren't familiar with your background, could you just tell us a little bit about yourself and how you came to be involved in cryptocurrency and find yourself at Blockstack?
Yeah, sure. So before this, I was a PhD student at Princeton. Munib and I were classmates very far back in the day, before OneName existed, before Blockstack existed. My involvement with crypto was pretty minimal until I joined Blockstack. Then it was called OneName. Munib hired me on as a contractor at first in May of 2015 to start working on porting the system off of Namecoin to Bitcoin, and that was my first task there. And then, the rest is history. OneName rebranded itself as Blockstack. We transitioned from building an identity system to building a full-fledged platform for decentralized applications, and here we are today.
Yeah. So tell us a little bit, you touched right there on the history of Blockstack, originally built on top of Namecoin to, and correct me where I go stray here, the issue there was making human readable wallet addresses, was kind of the original mission goal, the original mission statement. And for anybody who's watched the epic rap battle of history between Alexander Hamilton and Satoshi Nakamoto, that's definitely a ping that Alexander Hamilton had, one typo in your address and it's gone forever. So obviously that's something that everybody in cryptocurrency, it's kind of one of two things. You're either on the outside looking in, you've never sent or owned Bitcoin, and then you see the long, very imposing wallet address, and you're like, maybe tomorrow. Or you're in the space and you've learned to get over it, right? But unfortunately, would you agree here that there's a big security vulnerability there? And this is something that I talk a lot about. In general, if we look at what people actually do with sending Bitcoin, they just copy paste the address. They're not manually typing it in. They're generally not double verifying. Like, for example, I send Bitcoin all the time. And I often just look at the first 4 characters and the last four characters. And I've never been wrong yet. But obviously, if I just knew, I could go to any device that is universal and plug in, I want to send to Jude, right? There's no error possible. Would you say that was, am I on the right track there? Was that the impetus of the problem that you guys saw with this project in the first place?
Yeah, for sure. Like before OneName, you could just see a Bitcoin address, and maybe it's the right Bitcoin address, maybe it's not. Surely it's a well-formed Bitcoin address, so your money's going to go somewhere, but it might not be the somewhere that you expected. If you could find some way to tie that Bitcoin address to a name, or better yet, some other social proofs that gave you a greater degree of confidence that this is the Bitcoin address belonging to Justin and not Jude, who's trying to steal Justin's Bitcoin, that would make the user's lives a lot easier. And this is all, of course, necessary because, unlike conventional payment mechanisms, there are no second chances in Bitcoin. That once sent, there's no undo, there's no reverse, the money's gone, the money's transferred. So it's very important to get it right the first time.
Of course. Now, again, correct me where I go astray, isn't that inconvenience part of the underlying security that Bitcoin was trying to bring to the table? So you talked there, the issue is because the Bitcoin address that we're sending to is not tied to a personal identity. But isn't that the original concept, the pseudonymous nature of the Bitcoin blockchain in the first place? How can you get around that from a conceptual point of view? How can you get around that problem and still not reveal personal information in a way that ties one's identity, perhaps in a way that they might not want?
Oh, sure. So we definitely respect that, and the original OneName software, and today even the current Blockstack software, lets you be as anonymous as you want. You can have 0 social proofs, and many people do. You can have 1, you can have 2, you can have pseudo-anonymous social proofs. You can have a doing business as account, so you could have an account for your LLC that you have, and then it's not tied to you. But you can still withdraw the funds later on because it's still you behind the curtains. So we leave that choice up to our users. It's not our place to tell people how much they have to divulge. We leave that completely to the user's discretion. We just try to make it easier, more convenient for people for whom just a Bitcoin address is not enough.
Sure. So the quest to go from look at this big jumble of characters to a human readable address and to solve those problems that we just talked about, obviously morphed into a much bigger project. And you guys really took a step back and you said, well, how can we do this from the ground up? And that led to what Blockstack is now. So can you tell me a little bit behind the scenes, like what it was like moving from that transition? Like, when was the moment you guys decided to go back and do what you're doing now, which is the entire decentralized web, and maybe talk about that a little bit as well for people who might not know what I'm talking about?
Sure. So the back in the day, like the name of the game was decentralized identity systems, and how do you make those work? Well, to make those work, you got to have assuming you don't want a Bitcoin address, and there's plenty of user experience research suggesting that Bitcoin addresses or PGP key IDs or other sorts of non-human understandable strings of data are not ideal, because they're easy to forget, they're hard to pass around, they don't carry any semantic information or relevant information at all. So having a way to give a human chosen name, even if it's not your personal name, but even something like mybusiness.llc or something like that, is certainly be a step up from a usability standpoint, just for Bitcoin addresses. But the minute you start trying to bind a name and some extra state, such as a social proof or other information like some data or some attestations, you start needing some sort of persistent storage system. Like, where's that data live? How do you make sure that data stays around? You can't just put it on somebody's laptop and hope for the best, because they turn the laptop off, then the data's gone.
Sure.
So that implicitly requires, so like a rich identity system like that implicitly requires a storage system behind the scenes to handle that. But then now who controls the storage system? Like, can that be censored? Can that be taken offline? How do you ensure that the people who own the identity also own these extra pieces of state and control who gets to see them, or when or if they get taken offline? So in order to make that happen, we had to build up a storage system behind the scenes, and then we had to build it in a way so that users could individually control where their data lived and who got to see it. And we, at some point, I think it was middle of 2015, Muneeb and I were standing in front of a whiteboard looking at the system diagram of one name and thought to ourselves, like, this is starting to look more like an operating system kernel than it is an identity system. And that's when we had this aha moment that, oh hey, like in order to build a good identity system like this, you need to have some sort of decentralized computing platform, of which an identity system is one application. But now you have a whole platform here, like you might as well open it up to other applications. And that's about when one name became Blockstack.
Right.
We saw this as a way to start building many different types of decentralized applications where users own their data and they own their identities. And social verifications and Bitcoin addresses are just one of many possibilities there.
Gotcha. So I'll just, the way that I understand Blockstack is you are building an alternative to the internet. So right now people pull up their mobile phone or people go to their laptop and they click Google Chrome, right? They're in Windows 10 or maybe they're on Linux, they're using Firefox or whatever have you, Tor browser if they're trading cryptocurrency nowadays. And they go to Chrome and they're going to Chrome, they're visiting different websites, and you have SSL encryption, you're using TCP obviously, which that's not being replaced. That additional, the protocol layer is not being replaced. But your guys' vision is, again, I don't know how else to put it, but just redoing the whole thing, right? So now the internet, so this network that we all connect on, is one thing, and it's built from the ground up to be distributed, to be decentralized. And when you log into the internet now, instead of relying on your IP address or your MAC address, or again, going to these individual websites, creating a user account for each of them, which requires, now you need Dashlane, now you need LastPass, now you're juggling all these passwords. Man, I am in Bali right now, I forgot my two-factor authentication. This sucks. I can't log into BitMEX right now and clear this short. You want to build that in. Again, just as you were saying, that application should be built into the web from a fundamental layer. And then you can build other apps on top of that integrate with that. So now, when I go to the Blockstack Facebook, I go to the Blockstack Amazon, all the different websites, these are individual applications, correct? Do I have that right? Kind of the way I visualize it in my head?
Yeah, certainly. So I should just want to set the record straight here. We're not trying to replace TCP per se, because the internet, the underlying protocols of the internet are already decentralized.
Right.
They were designed that way.
To survive nuclear war, actually.
Precisely. Yeah. It's just the web apps are not like that at all, because all the data, all the identities, all the state, all the authoritative, legitimate views of that data are all served by the single application provider. And they're basically God in their own domain. They decide what's real, what's not real, and that's where the abuse comes in. It also is where a lot of the user hassle comes in. Even if everything is working right, you can still lose your password, use your second factor, as you pointed out, and you're locked out effectively.
Sure.
So where Blockstack comes in is we make it so that the application is no longer responsible for managing identities or state. All they are in the limit is just a front-end website that you bring your identity and your storage to. So when you log into a Blockstack app, The sign-in process is really connecting just the web page itself to your back-end storage that you've chosen and you've set up and you own, and also providing that application a identity that is cryptographically linked to your identity, but in a non-repudiable and partially disclosable manner. So the high-level idea there is that there's no longer a need for this silo of data. You can get the same user experience without it because you've hooked in your storage to the app. The app is now going to send its reads and its writes to your storage instead of to a backend service. You can take your data with you. You can't be locked into an app anymore. You can extract your data. You can modify it in place. You don't need the app's help or permission to do this any longer. Sure. You can take data from several different apps and combine it in new ways to help you realize values you wouldn't be able to have today. Here's a good example in trading. Like if you had several different trading apps and you wanted to, merge the intelligence you've gathered in each of these separate trading apps into a single coherent view, you can do that now. But you can't easily do that today. Because
again, it's almost like every single web page, or to use the better words, domain. Each individual domain is its own city, right? And when you go into a new domain, hey man, we better familiarize ourselves with the laws here. Where are the cool places to eat? Where, who should you not talk to? And that's a more broader way of saying they set the rules, and you're going to be playing by different rules. And transmitting data in and data out is relying upon their decision. So what you're talking about is giving the user ownership of their data. You talked about it being stored locally and encrypted on their own device or a device of their choosing?
Device of their choosing. If you want it to be, generally speaking, you'll want your data to be available if your device is turned off. Just because you switch devices or you maybe do something on your phone, then you try to get at it from your laptop while your phone's turned off.
Sure.
What we ensure is that the data is encrypted end to end. So we make it so you can do things like store your app data on an S3 bucket or your personal server or your Dropbox, but they're none the wiser. As far as Dropbox and S3, et cetera, are concerned, they're just dumb hard drives.
Right.
Just like how you don't really care what brand of hard drive is in your laptop, just as long as it works.
Right.
Similar for cloud storage. All they can do is not serve the data, but then we've made them interchangeable and replaceable. So the only way they make money is by keeping your data online to the greatest extent possible.
Right. So that you've kind of removed that from a social engineering standpoint, the incentive for them to do such a thing, which is again block the sending and receiving or transmission of your data, which is what allows you to access what you want to access on the web.
We've aligned their incentives.
Yep. And the way that I remember hearing Munib explain it was kind of the locker system, right? And I think that's what you were just explaining.
Yes.
So as it is right now, I use Google Photos. So every single individual image file of mine is on Google Photos. Google, their cloud, and their company that has a fiat control over that entire system sees all my data and can read it in the same way that I can. This way is different. You're talking about, instead of uploading the individual files essentially, I am uploading a folder. In that folder, I can see all my files exactly how I put them on there. They can't. They just see a folder. And they just see data packets going in and out of folder.
Yep, that's correct. Our underlying storage system, Gaia, is what implements that abstraction, the data locker abstraction. So all you do when you sign into a Blockstack app is you're hooking in your data locker to the application's front end, and they can load and store files just for themselves, but not for other applications. So while you're signed in, the app can see the data that you've put in, but that's already the case. You're sending your data in the clear through the app. It gets encrypted on the way out of your device, and then sent to your data locker for safekeeping. And that's where to speak further, to go back a bit to the identity topic there, the only reason you even need an identity at all is just to make it so that some data in your data locker can be discovered by the people you trust.
Right.
Because if you don't need that, you don't need identity, period. You can be, and there are some prominent Blockstack apps like Note Riot, for example, or eTaxi, or some crypto wallets that we have built in our system, where you don't need an identity, period. You just have your data locker and you're completely anonymous. The data is just encrypted and stored, just otherwise normally.
You're talking, so if I'm going to a website where I don't need to log in, why do I need an identity?
You don't.
It's a public website. There's no reason for you guys to be pulling any data from me, except for the regime that we kind of have right now, which is data harvesting. There's financial incentive in harvesting data, right?
And we don't
whether
want
it's selling location data, whether it's selling personal preference data, whatever it might be. And we should have control over that. So kind of an ethos that I'm seeing here is empowering individuals to monetize their own data or make decisions on how their data is utilized by third parties.
Definitely the latter. Monetization is certainly one route for people, but I think a lot of people would prefer to remain private as well.
For sure, of course, especially as we continue to progress further in this realm. Okay, so Let me think here. Where do I want to take this? Tell me about some applications that you guys have already built or had built by developers on top of Blockstack right now, and kind of what's exciting right now. Where are you guys going? What's the new developments, kind of taking place at Blockstack?
Sure. I just want to emphasize, like, up until now, all of our apps don't need tokens to operate, and they don't need smart contracts to operate. They're just front-end websites that are served out of like a static S3 bucket somewhere. And that's really powerful because it means their operating expenditure is basically zero. You make the website, you throw it up, and you walk away. You're done. You could be hit by a bus the next day, and the app would keep going on. Not that I hope that happens to anybody, of course.
Sure.
But our most popular app right now is an app called Graphite Docs. It's a replacement for the G Suite. It lets you do Google Docs. It lets you do file storage, photos, I think is what it can do nowadays. But the idea is that it gives you the same user convenience. You can edit documents and share them with your friends and see their edits in real time, but it's all end-to-end encrypted, so it's only your friends that get to see it.
Okay.
We have a similar suite of apps called Arcane Docs that can do this as well for sheets and for documents. There's competitors, and soon it will be possible for these apps to share the data with each other with the user's consent and permission, of course.
Cool.
Another popular app, you mentioned Google Photos. We have Recall Photos, which does largely the same thing. You store your photos. They're time series, so you can search through them like you would normally search through them, but only you can see them, only you and your friends. Third category of app that's getting increasingly popular are file sharing apps. We have XOR Drive, we have Black Hole. Both of those apps are ways for people to turn their data locker into something that looks like Google Drive, but gives you the privacy guarantees of that data locker.
Okay.
So only you can see it, but you can choose to share it with your friends, and then only your friends can see it. And that works. That's been working out so far. They're in the top 10 most popular apps as far as we're able to track them. And keep in mind, we can only see apps that require the user to be able to share data. So there's other apps that are completely private that we don't track and can't track.
Can't track, right. So that's completely feasible right now. If I wanted to, I could go home to my laptop, or my laptop's in my bag over there, but I could get my laptop out and download Blockstack, download the application, and switch over from Google Photos.
You could.
I could do that right now, and it would be, obviously I wouldn't have the convenience probably on my phone, on my mobile device, right? But it would be a realistic alternative that could handle the data that I could utilize right now today.
That's correct. We have mobile SDKs that are under development right now that will allow for native apps to do this, and we hope to get those done hopefully in the next few months.
Really?
Yes, because obviously, like mobile is king. It's it's the first device the vast majority of people on Earth use to get to the internet. So we definitely want to be working in service there. It's just the mobile app operating systems make this harder. The sorts of things that we would like to do.
And so this would work with having the Blockstack application on the mobile device.
Yep.
And once you have that, you just have the same access to whatever. You'd have to optimize for mobile for the different devices, just like regular app or web page development now. But
certainly,
you're running the same running the same application, and you're just accessing different areas of the application inside, right?
And we have that today, as long as you're willing and able to use your mobile browser to do it. It's just native apps are still something we're working on.
So you can kind of access like a Docker from your mobile device and get into there somehow, a container.
Not quite. It's actually easier than that. So the way that you onboard on Blockstack is your identities are all derived from a seed phrase, like a BIP39 seed phrase. So if you put that same seed phrase on your mobile device, you have all your identities right there. Cool. It's just you'd be using the hosted version of the Blockstack Wallet for managing your identities, which is less safe because you're fetching a page remotely and doing it as opposed to using a native app. But it would still let you handle the sign-in process. At least when I tried it on Android, it was working. It
was working. Is that in the same realm of having my data locally stored, right?
In the same realm, the data is not. The data would not necessarily have to be locally stored because again, you would want to make it available to your desktop later. But that's certainly an option for you.
So that process that would be taken care of when I initially set up. I don't know what word to use. Is Blockstack account, is that kind of in the right realm, kind of right area, identity, right?
Yeah, like a Blockstack ID, I think is the term we use these days.
Yeah, and then it asks, so where do you want to store all this data? And you're like, here's my server over here, right?
Okay. Yeah. So that would be where like a Docker image might come in. The specific configuration of that is really up to the user. We have tutorials on how to set one up in EC2, for example, or set one up on DigitalOcean, or set one up locally. So wherever you can put it, and wherever you can make it publicly routable, so your phone can get at it, it's totally fine.
Great.
It just speaks HTTP under the hood. So wherever you can run the HTTP server, you can put this.
Okay, great. Now, from what I understand, this Blockstack piggybacks off of Bitcoin hashing power for its security. And what is the term you guys use again?
So we under the hood, we use a protocol called a virtual chain. We're getting kind of deep into the weeds here, and this is something that we don't really talk about too much because it's not really relevant to users. But all that we do, but we do have a couple academic papers on this. Under the hood, we treat the blockchain itself as a way to store a replayable database log. So every time someone registers a name or transfers their name's key or changes where their data locker is hosted for that name, they issue a Bitcoin transaction. And that Bitcoin transaction includes an op return output that contains a few bytes of metadata, up to 80 bytes, I think, that is interpreted by the Blockstack nodes around the world as a database operation, like select an update or an insert or a delete, the same things you might do on a SQL database.
Sure.
And because the Bitcoin blockchain is extremely hard to reorg after a certain number of confirmations, every Blockstack node will see the same history of operations and will be able to independently calculate everybody's name to public key to data locker mapping. We have a way to, so that's just like the base case, the simple way you do it if you just want to send Bitcoin transactions, but that doesn't really scale too well. So we have a second system that allows us to batch off-chain name registrations at a rate of about 160 per one Bitcoin transaction. And the way we do that is, and that's the default way we onboard users because it's effectively free for users at that point.
Sure.
It's like half a cent per user, username at current transaction rates. But it gives you the same safety properties. Only you own the name, only you can issue updates, only you can issue transfers. But it's way more scalable. We can onboard 115,000 users per day using 3.4% of Bitcoin's transaction volume, which is about the same of what Twitter onboards users at.
Sure.
And so when you onboard with Blockstack, that's the first ID we give you. You can register on-chain names afterwards, and we see people do this. I have my nodes log open all the time on my laptop, and every block I see 3 or 4 Blockstack transactions or so of people registering names or transferring them or doing token transfers and things like that.
On the Bitcoin blockchain?
Yep, it's all embedded inside of op returns on the Bitcoin chain for the time being. That's the state of the world from 2015 until now. We're building a second generation blockchain right now that should be released sometime late Q1 next year that has a mining algorithm called a tunable proofs system.
Yeah, tunable proof of work, right? And that's kind of what I was getting at, or what I was familiar with anyways, yeah.
Yeah, so like I said, we don't talk about the virtual chain stuff too much because it's about to disappear.
Right.
But that's the way it's worked for the last few years.
So just to touch on that, so you're saying that right now to register a Blockstack ID or to get started with Blockstack, I do have to use the Bitcoin blockchain. I have to send one transaction, right?
Either directly or indirectly. If you want to register it yourself, you pay for it yourself, or you can go through our registrar and we can issue a batch of names, so your name will be included with a bunch of other names at about the same time.
Okay.
And that's how you would get onboarded.
Gotcha.
But either way, there's a cryptographic proof that your name exists, was registered at this block height, and that your key owns it. So you have the same kinds of safety properties.
Cool. Neat.
With tunable proofs, there's a few undesirable things about the current system. There's no mining. There's no way to deal with Bitcoin forks if that does happen. There's no way to do smart contracts easily, and there's a increasingly large use case for those. So what we've been working on for the past year and hope to release sometime early next year is the Stacks version 2 blockchain, where instead of embedding each Blockstack transaction inside of a Bitcoin transaction, you mine entire blocks of Stacks transactions in parallel to the Bitcoin chain. In the act of mining, the tunable proofs operates by miners provably destroying some Bitcoin on chain, as well as burning some electricity and submitting a proof of work. They have the choice as to how much Bitcoin they want to destroy versus how much work they want to do, and that's why we call it a tunable proof. But the point is, the act of destroying energy or Bitcoin is fed into a cryptographic sortition algorithm, such that the more you burn, the higher the chance that you get picked as the next winner in the block race.
Okay.
And everybody learns the same sequence of winners, so it's a verifiable random function under the hood that gets used to pick that winner in a way that can't be biased, except by burning more Bitcoin, which is the whole point of this.
Right.
But if you win the block race, you get to mine the next Stacks block that has a Coinbase attached to it. You get more Stacks tokens this way. You process name registrations, name updates, but also more generally smart contract instantiation and smart contract method calls. And the act of continuously destroying Bitcoin and doing energy expenditure this way is what allows the chain to make progress. So this is nice because it's somewhat greener than Bitcoin. You're not spending nearly as much energy as you would be by mining a chain the size and scale and scope of Bitcoin.
Right.
But we're still recycling Bitcoin's hash power because the act of destroying Bitcoin is basically free. But you still get the Bitcoin hash power securing the order of those instructions, which is what gets fed into our mining algorithm.
Mm-hmm. So right now, the benefits that I see from this are, one of the biggest issues is, how wasteful is, proof of work mining, and can it scale, and is it large enough? You guys have found a way to utilize, but we do know it's very secure. We know it's very hard to gain. So you guys are utilizing that to secure your own network and make sure that when somebody has a Blockstack ID, that's their ID, and we can prove it, and it's verifiable, and it's non-manipulatable. But you've also been able to take this idea, but right now there's no mining system, there's no incentive. You actually have to, in this case, purchase more Stacks tokens to have more Stacks tokens, right? There's no way to earn them unless, I'm like, Jude, would you send me 5 stacks? And he's like, yeah, no problem, and here's 5 stacks, right, type of situation. But with the tunable proof of work, which you guys will be implementing, you have an active incentive. Now, what's the incentive for that? What does the individual have to do on the Stacks network? Again, do they have to kind of hop back to the Bitcoin network to take advantage of this? How do they get the Coinbase?
I see. So just like how it works now, you'd run a Blockstack node, it would track the Bitcoin chain and look for these tunable proofs on chain, and doing so, figure out what the sequence of block headers are, what the parent-child relationships are, what forks exist, and then that node talks to other nodes like a normal cryptocurrency node would, and gets the block data, replays the transactions, and figures out the current state of the world.
Gotcha.
So you spoke of waste earlier. The thing about this is that we're basically building a parallel blockchain to Bitcoin, using Bitcoin's hash power to secure it, but without having to burn any more energy.
Gotcha.
So Bitcoin is now securing 2 chains.
Right.
So
it's almost like you're using your ant miner to toast your bread.
Yeah, you're getting. It's not that proof of work is inherently wasteful. It's just underutilized.
Right.
That's the way I see it. So Bitcoin's proof of work could be used to secure a whole bunch of chains built in this manner.
Sure.
And we actually see that as our scalability avenue, because just as how you can destroy Bitcoin to mine blocks in the Stacks chain, you can destroy Stacks tokens to produce what we call app chains, like application-specific blockchains, who are then protected from reorgs by the security of the Stacks chain. And this idea generalizes. You can have chains stacked on chains, all stacked on the Bitcoin chain, which is keeping it all together. So in doing so, like, the proof of work of Bitcoin is serving many more purposes than just securing the Bitcoin chain.
Sure.
And so Bitcoin is not wasteful, it's just not being put to its full capacity.
Yeah, I mean, again, not to get simple with it, but I think about all the heat that is generated from Bitcoin miners and how much cost that could reduce from our energy consumption right now in the HVAC system, right? That's a very broad application, and so I think you're absolutely right. Obviously, that's more, how can we utilize the security function, the hashing power to secure another chain in a cryptographic way? But yeah, I absolutely agree, man.
So yeah, you destroy some Bitcoin with the Chainable Proof. The point of doing the Chainable Proof is because it gives us a way to bootstrap a proof of work network in parallel as an escape route. Like, I don't say this lightly. I don't think Bitcoin is going anywhere for a long, long time. But we learned our lesson with Namecoin. Like, it is possible for blockchains to rise and fall in prominence, and the Tunable Proofs mechanism is just a way for us to keep our users safe in case something bad happens to Bitcoin down the road. Which, again, I really hope does not happen. That would be a world of hurt for us, for everyone, for the whole space. So when I speak of tunable proofs, like, a good way to think about it is just like a way to recycle Bitcoin's hash power. Spending the energy part is just a way to add a built-in safety feature for our users. Anyway.
So right now, obviously, you guys have the Stacks token, which is utilized to register domain names or register identity on the network, right?
Yep.
So again, correct me where I go astray, just asking the question so I understand. You said whether directly or indirectly, one is going to have to send a particular Bitcoin transaction on the Bitcoin network, right? And that has to deal with what is in the op return code, right? Now, from that registering of your identity, your initial time, that doesn't also require Stacks? Stacks doesn't have to be sent on the network, or is there Stacks sent in that scenario? Just to help me understand how that kind of works.
Yeah, for sure. So right now, the way the system is built, you can pay in either Bitcoin or Stacks for some types of namespaces.
Gotcha.
Like the ID namespace, which is by far the most widely used one. That can take both. Future namespaces, when Stacks v2 goes live, it will all happen in Stacks. There will be no need for users to interact with the Bitcoin chain.
That's why
directly.
you talked about getting away from that. What did you call it? Infinity chain, or?
I'm sorry?
What was the word that you had for, you're like under the hood, the infinity chain, you guys are moving to tunable proofs is what you're talking about?
Oh yeah, we had the virtual chain under the hood.
Virtual chain, right.
Yeah, and then this will have the tunable proofs in the mining system. But But the with the new mining system, we'll have native support for native blocks and native transactions that are designed by us. They're not embedded inside of the Bitcoin chain. Miners will run nodes that do mining and have a mempool full of transactions that will get packaged into blocks. But as far as the user experience is concerned, users are now interacting with the system directly in stacks. Only miners have to know about Bitcoin at all, because miners have to burn Bitcoin to mine blocks, or at the very least register their block hashes.
Right.
So the user experience now is still going to be preserved across the upgrade to Stacks v2. They can either register a name directly and pay in stacks for it, or they can get somebody else to sponsor their registration for them. The Stacks transaction wire format has two modes of payment, the first of which you pay directly, the second of which is someone else sponsors your transaction, but the transaction operates under your authority. So we intend to take our registrar right now that does that anchoring mechanism I mentioned earlier, batching name registrations to a single Bitcoin transaction. We intend to do something similar in Stacks v2. Similarly, the registrar will gather name registration transactions and it will send a batch of them as a large Stacks transaction, but it'll be paid for by the registrar, not the user, which is important to us because we want users to have as low friction onboarding as possible. So it will still be free for users.
Excellent.
And we just foot the bill for however much those transactions cost.
So in the realm of, obviously approaching the space as a trader, what is kind of happening on the Stacks platform that I should be excited about?
Sure. So the one thing that Stacks v2 is bringing to the table is a smart contract language called Clarity. And Clarity is built from two perspectives. The first perspective, of course, is Blockstack's overarching ethos of can't be evil. Like, how can we keep users safe and stop apps from abusing users? And the second ethos is more practical. It's what can we learn from all the previous blockchains with smart contracts and not repeat their mistakes?
Sure.
But fortunately, there's a lot of overlap between these two, so it makes our job a little bit easier. Clarity is a decidable smart contract language. Some people wrongly use the term Turing incomplete or Turing complete to describe this, but decidable just means that it's possible to know what the contract will do before you run it, before you send a transaction. And that's important because it lets you as somebody who interacts with blockchains to do things like move tokens around or call into methods to execute some application-specific feature. You would like to know what's going to happen before you do that, because blockchains, as we all know too well, they don't forgive and they don't forget, and there's no undo button.
I think the whole point is they're immutable. Yeah.
They are. So Clarity's decidable language. You can tell what the code will do beforehand. Unlike a lot of smart contract systems, this means that we don't have an out of gas error. Like, we know you will be able to tell what the transaction fee should be before you send the transaction, so your transactions get mined or they don't get mined. They don't get mined and then nothing happens.
Right.
The way that it happens in some other platforms. The second cool thing we have is that we are immune to a large category of bugs that are in the compiler for smart contracts. So systems that use like WASM or other sort of virtual machine under the hood have this interesting set of vulnerabilities where the compiler that translates the human readable source code down into the machine code, if it has bugs, it's really hard to know if those bugs were, even that those bugs happened, because, you'll know that there was a bug, like the transaction behaves wrongly or the smart contract behaves wrongly, but how do you attribute the bug? Is it a bug in the smart contract itself, or was it a bug in the compiler?
Right.
Or was it a bug in the VM itself?
Yeah, right.
And that leads to uncomfortable questions like, who do we blame? Or how do we, is this something we have to hard fork over?
Right.
So we sidestep the whole thing by writing the source code directly to the chain itself. So no more compiler, everything's interpreted in place, and it also is great for transparency from a transparency perspective, because now you always have the source code available. You can audit it just by looking directly at the chain and see what's going to happen. Cool. The third property we have that I think people who do a lot of trading are going to appreciate a lot is we have a notion of post conditions in our system. So post conditions are statements that have to be true about your account when the transaction finishes. When you send a Stacks transaction, it can have some code that runs and then a list of post conditions that the system will evaluate over your account to make sure that everything is all fine and good. That can be things like, when this transaction finishes, I will have sent no more than 1 Stacks. Or when this name finishes, I will own this particular NFT. I will own this particular Blockstack ID, or things of that nature. This will be exposed to users in the wallet itself, so they can set whatever post conditions that they want before they send a transaction. And if any of those post conditions are violated when the transaction runs, the transaction aborts. No changes take place. The user is just out their transaction fee and nothing more. That's important because it allows users to proactively defend themselves against buggy smart contracts. You don't have to worry about, you call into this contract, it calls into this other contract, calls into this third one, and then it steals your money. That can't happen if you have the right post conditions. This is especially good for people who trade or operate exchanges because they can set post conditions in all trades that go through, so users can't do things like empty your hot wallet by exploiting a bug somewhere else.
So basically, the way I'm understanding it is, we can set a condition in our smart contract language that says when all of this is done, this is what should be coming out the other end. And if that's not true, pull it back, Sally, pull it back.
Absolutely.
Right? Okay, cool. Yeah.
And it's first class, so it's guaranteed to always run. It's guaranteed to always be there. It doesn't matter what the code is, what the code looks like, because it's natively supported.
Great.
And as far as I know, we're the only system that does this.
Got to be a pioneer, man. Awesome. So, okay, we touched a little bit earlier on kind of where Blockstack is at right now. And again, I don't know, exactly what you can speak to or what you feel comfortable talking about, but you guys are the first, I believe, token offering in the United States that got A+ regulation approval, correct?
Yep. And
you guys just finished your funding window because after you got that approval, you had 60 days, I believe by default, by the language of the SEC, to do your token offering. So you guys are done with that. So people cannot participate anymore in the token offering, correct? That's closed,
That's
right?
Closed.
The initial round is closed. And,
yes.
I'm not exactly sure what your guys' plans are for things that might follow. If y'all have additional funding rounds or whatever, again, I'll leave that to the primers. But individuals that have invested in the Stacks token have Stacks right now and invested in the building of this infrastructure. You guys right now, I would assume, are focused on just building up infrastructure. Well, not infrastructure, but probably putting tokens in people's hands. Just getting it distributed, getting people utilizing the platform, getting people developing. Correct me where I go astray.
Yeah, that's the whole point behind this. Like the Reg A. The Reg A sale allowed people who, so at the very beginning, we did our Reg D in 2017, we gave out vouchers to, we allowed community members to come forth and register vouchers from us, which would, they're not legally binding in any way, but they would say if we ever do a future sale, you'll have the same strike price as the Reg D investors. We just can't sell it to you right now.
That was the 12-cent ticket.
Exactly.
Yeah.
It's just, the law prevented us from selling directly to unaccredited investors.
Sure.
So the Reg A was all about empowering our early community members and empowering people who were interested in the project who were unaccredited, and people who got those vouchers were able to, were able to participate in the same way that the Reg D investors did.
Great.
We wanted to uphold the end of our promise to our community. So yeah, but I can't talk too much more about any future plans.
Sure.
About
absolutely. Just for clarity here too as well, have the tokens been distributed to the individuals that participated in the initial offering?
Yep.
So the Stacks wallet's downloadable onto your machine, and your Stacks tokens are in there if you participated. Great. And again, what can I do right now? I mean, we talked about the Google Photos, man. Honestly, you could probably go on and on about the different things that I could do. Email.
We have that. We have
Check.
Yep.
Amazon.
Emails. I believe so.
Marketplaces. Okay. Great.
I know we have some people working on this now.
Yeah.
I know that my that emails are more evolved than the one of the more evolved apps we have. We have D-mails, which lets you send end-to-end encrypted messages between Blockstack users, and I know they're working on a feature that lets you send it to people who don't use D-mails yet, so you have backwards compatibility.
Cool. Messaging apps.
Yep, we have several.
Cool.
Stealthy is probably the most popular one.
Okay. Tinder.
I don't know actually.
working
not now,
on
then
it.
soon.
Yeah. Gotcha.
See, we can't track all of the apps.
Gotcha. Because you have independent developers working on it. Would you have a rough idea of how many people you would think are actively working and developing on Stacks at this moment?
So we, the only way we keep track of that is through our app mining program.
Sure.
We have over 270 apps participating so far, and each of those is at least one person.
Cool.
Lots of them are more than one person. But beyond that, I know we've done partnerships with Lightning Labs, for example, where people build Lightning apps, people using Blockstack as the authentication and storage for the app. I don't know how many of those are on app mining, but there are some that I know there are a lot that are not. So there's that category of app as well. And then there's people who just build on the platform because they like it,
Yeah.
and they may or may not talk to us. I know of at least one wallet producer has been registering a bunch of names right now in our system for use in their crypto wallet app, and I haven't spoken to them yet.
Sure.
So that's always exciting to see.
They're just, hey, we're here, we like what you're doing, and we're going to develop here. You got a problem with that? Doesn't matter.
Yeah. We welcome everyone. Like,
Cool.
We can't stop you from building apps. That'd be
I
terrible.
think it's great. Well, you want to grow the network and build it, man. That's great, man. And again, I can see the, I talk to a lot of people, so I can generally tell when somebody really enjoys what they're doing. It seems like you enjoy what you're doing, man.
Absolutely.
So, what's kind of the last few minutes here, like, what got you into crypto, man? Like, what was the, what gave you the bug?
It's funny you say that, because for a long time I hated crypto.
Yeah.
I thought it was a scam, and it was like this crazy sort of thing that could never possibly replace money.
Right.
So what got me interested in crypto was the fact that you could use Bitcoin for far more than just a speculative asset.
Right.
At first, it was our way to do name registrations and build the backbone of a decentralized application platform. That excites me a lot. In fact, I was able to. I was so blessed to be hired at the time that I was, because I was able to use the technology we were building at Blockstack to help finish my PhD thesis. Mm-hmm. And there's a chapter or two, or in some paragraphs and sections, about like how we bootstrap security in the system precisely because we have this untrusted but publicly auditable ledger that contains all of the name registrations in here. And Bitcoin serves a vital purpose in that, because A, it deputizes a whole bunch of people to keep it secure for us by watching it, mm-hmm. and B, it gives them an incentive to keep it secure. In other words, to keep the transactions in the same order forever, which in turn underpins the security of Blockstack.
It's kind of like, we're building something here, we need to make it secure, how can we do that? Mm-hmm. Oh, you guys got that figured out. We can just borrow that, and it's just sitting there. Again, kind of like we talked about earlier, it's not that Bitcoin mining is inefficient, not the proof of work is inefficient, it's underutilized.
Yeah.
Look at all that, the security, the possibilities, the options that are there. All people have to do is bootstrap off of it or piggyback off of it, because it's there. It's almost like, if there was just zero energy flowing around and the technology existed to just reach out and capture it, and people still fired up coal engines, that wouldn't make a whole lot of sense,
Yeah, and like, if you want to speak about the raw power, like, I mean, sure, one day like Bitcoin mining ought to be powered completely by green energy, and that's a future that I think we can build towards. But again, like the amount of energy put into calculating, partial hash pre-images is really a function of like how much the market will bear, and in the future, hopefully, it'll be a way for us to bootstrap other systems that use Bitcoin to underpin it as security. So it's not inefficient. It's just not put to its full potential.
Gotcha. So you got the crypto bug for good reasons. A lot of people get in because they're like, man, look at that big candle. You came in because of its direct application to secure what you are already developing.
Yes.
And I think that's really amazing, man. Where do you see us? Obviously crypto's facing a lot of issues right now. I wouldn't say issues, but we're in an interesting time. We have regulatory uncertainty. We have obviously a ton of money sloshing around. We have, kind of overall the sentiment in cryptocurrency, because we're coming off the tails of a very long and pronounced bear market, not only in the major asset Bitcoin, but all the other majors as well. And the last, 6 or 7 months has been like pretty amazing, honestly, and a wild ride. Mm-hmm. So, from wherever you sit in the market, like just kind of what are your opinions on where we're at? What do you kind of see on the horizon of the future, or maybe what are the pressing issues that we're kind of dealing with right now?
So I mean, I know I have the guilty pleasure of going on CoinMarketCap every day just to see what's up, even though I know in like my super ego that it's all fake, it's all tethers, it's all
right,
it's all speculation, it's all wash trading. But so I try not to take it too seriously. Like short term, it's going to go up and down, it's going to do a bunch of different things. I'm not focused on that myself. I'm focused on building the long-term value and making Blockstack the best system it possibly can be.
Great.
I'm happy as long as Bitcoin stays around.
Yeah.
I'm easy to keep happy that way.
Cool. I like it. I think the sentiment we'd hear from a lot of other people, that we've heard from a lot of people, like, as long as we can stay above 5,000, if we just stay above 5,000, we'll be pretty happy. You know what I mean? Just doesn't matter what happens after that.
Maybe I should phrase it differently. I'm happy as long as Bitcoin doesn't get reorged.
There you go. Exactly. I think that's kind of the fundamental issue. Mm-hmm. Actually, that just brought me up, because I actually haven't had this conversation. Do you have any opinions on, Bitcoin, Bitcoin Cash, Bitcoin SV?
I mean, you can make a fork at any point in time.
Sure.
So I lived through I didn't directly participate in the whole like SegWit yes, SegWit no thing, but I did see it happen. Mm-hmm. I don't know. My head's too deep in the weeds to really care. honestly.
Sure.
Bitcoin was not going to go anywhere and we had a forum post from back then saying like if something really bad happens and all the hash power moves over to Bitcoin Cash, our mantra is the same. We want to build on the most secure chain.
Naturally, that makes sense. Well, for what you guys are doing.
Mm-hmm.
I guess my question has always been, obviously we've talked a lot actually on this channel about explaining to people the entire way it went down with the BIP that was proposed to force miners to signal for SegWit, otherwise hard fork. We've talked about the New York Agreement. We kind of talked all that. It's one of probably the most germane, interesting conspiracy theory that we can sink our teeth into. I guess my general question is, do you feel that it seems like the Bitcoin Cash narrative, whether they're right or wrong, is that SegWit is the wrong direction, that big blocks are essential, and it seems like the core, Bitcoin core protocol, their argument is that no, we don't need to increase to blocks, and SegWit is the right way, layer 2 is the right way, building all things in this nature is the right way. Do you feel like it?
So
do you have a preference?
I do actually have pretty strong opinions on.
Okay.
So, somewhere deep in the bowels of our paper, our Dropbox paper internally stuff, we have this document called the Stacks Design Thesis, and in that document which I hope to make public one day, there's a section about myths about blockchains, and one of those myths is that blockchains can scale. Now let me unpack that for a second. A blockchain is an artifact, but it's an artifact of a social construct, a social agreement, a social contract between the people who run nodes. And in Bitcoin's case, that social contract means things like there are 21 million Bitcoins. They are released according to this schedule.
Right.
You produce more Bitcoins by doing the following things. You mine blocks with this format, you send transactions with this format, you can do the following things with these transactions, but not these other things. Like that's all a social contract. That's something that, by running a Bitcoin node, I'm voluntarily agreeing to. And I can join and leave whenever I want. But with that does have some pretty interesting implications for the design of blockchains, because in order for that social contract, another important element of that social contract is I can independently verify the state of my balance and everybody's balances by calculating the UTXO set. But in order for that to be attainable for the vast majority of people, they have to be able to process blocks faster than the network can produce them. So regardless of where you fall on should blocks be 1 megabyte, should blocks be 2 megabyte, that's not the right question to ask. Because the fundamental problem is you have to make sure that the people who want to participate can reasonably do so. And that necessarily puts a cap on how many transactions per second you can possibly send out. So you can do things like make it so you can process transactions faster, you can make it so you can represent more transactions in fewer space, but you're fundamentally capped by how many by the means of the least powerful node who you expect to reasonably participate.
Sure.
So blockchains are fundamentally unscalable systems. They shouldn't be. It's a good thing that they aren't, because that means that people can do that. They can audit the state of the chain. They can calculate the UTXO set. They don't have to worry about trusting somebody else to tell them what the state of the world is.
Sure. So you have the validation, instant validation.
Yeah, and that's how you're secure. That's how you know that your money is yours, and that's how you know the UTXOs you're spending are actually unspent still. So as long as that's true, then the blockchain can work out. But that fundamentally means that no matter how many nodes you throw at the blockchain, it cannot produce transactions more than a certain rate. And that certain rate is a function of what you expect the minimum hardware requirements are for the people who you expect to participate in your blockchain are.
Gotcha.
And that minimum requirement's going to be different for each people. Like some blockchains like EOS expect you to have a very beefy server to participate. And that's fair, that's their choice to make. Bitcoin's far more conservative in that capacity, and in doing so they're able to build a much bigger tent to include a lot more people in it, because they have much more meager hardware requirements to keep up with the chain. And there's between those two, there's a whole family of chains that make that trade-off differently. Like some require an SSD to run, for example, because the number of disk seeks you do per block is extremely high relative to, say, Bitcoin. Anyway, the answer to dealing with scalability isn't to make bigger blocks for that reason, because you're just kicking the can down the road.
Sure, exactly.
You need to figure out some sort of way to ensure that not everybody has to process all transactions. That's the only way you can go forward. And I think that we have a viable solution with our app chains here, and with Stacks, like Stacks being a prototypical example. Bitcoin doesn't have to care about the Stacks chain. People can run Bitcoin nodes and not run Stacks nodes, and everything's going to be fine. But similarly, people who care about the Stacks chain will need to run a Bitcoin node to get the history of burns and sortitions, and also run a Stacks node to audit the blocks.
Gotcha.
That idea, though, that some people only process transactions and other people don't have, for one chain, other people don't have to, that that divide is predicated on who cares about which transactions. Like obviously only people who care about the Stacks chain run Stacks nodes. People who don't care about the Stacks chain don't run Stacks nodes. We expect to generalize this so that applications that want their own chain or want their own token or want their own smart contract language can do so by running their own app chains that burn the Stacks token to produce app chain blocks. And in doing so, you only have to run nodes for the app chains for the apps that you care about.
Right.
So if I'm running the app chain for like Graphite Docs, if there is ever an app chain for Graphite Docs, but you don't use Graphite Docs, you don't have to worry about auditing that chain's history. So that in doing so, we've made it so that you only have to run validators for the chains that you care about, and we have a way to link those chains together so that they can all benefit from Bitcoin's underlying hash power to secure them all.
Great.
It makes some things more complicated, like having one app chain interact with another app chain has to be done through some sort of cross-chain atomic swap mechanism, which we're still working on. This is different from the, like, say, Ethereum 2.0 approach, where you have shards that somehow all keep coherent with one another. No comment on that. That every time you look at the spec, it's different. So whatever I say now is going to be wrong tomorrow. But anyway, like the key to scalability is making sure that you don't have to process the things that aren't relevant to you, but the system still remains secure by you not having to do that.
Yeah. So the main issue here is the security of the chain, not the scaling of the chain.
Yeah,
That's what's important.
Making sure that you keep up your end of the social contract there. Like you have to make it so that people can independently audit the set of transactions for the things that they care about, and you have to structure the system so that it's reasonable for most people to do this.
Right.
You shouldn't have to go spin up a 64-core, 1 terabyte of RAM server if your expectation is that every third person on Earth will be doing this.
Gotcha. Well, listen, man. I mean, honestly, like just being candid. There are very few projects that actually excite me. I was aware of Blockstacks, of Blockstack before and the Stacks token before we had this conversation. Whereas there's projects here that I've talked to where I am just now hearing about it, right? And so that's pretty interesting. And Stacks is one of the few that actually excited me as an individual. I think that you guys have a good approach. I think that you guys are doing a good thing, and it seems like you guys seem to know what you're doing in a proper way. You guys, it's not just having the right answers to the right questions. It's about putting pedal to the metal, but putting rubber to the road. And you guys have a product that works right now. You have active developers, and I think you're doing a good job, man. So pretty exciting stuff, man. I look forward to see what you guys come up with in the future. So, Jude, thank you so much for taking some time with me, my friend.
My pleasure.
Highly appreciate it, my friend. If you want to, you can tell them where to find you, or whatever kind of information about Blockstack or anything like that, if you so desire.
Yeah, sure. If you go to github.com/Blockstack, that's our project repos. Everything we do is open source. Our core software is GPL3, and we intend to keep it that way. We're all about transparency and making sure that anyone can contribute and participate. All the development for the blockchain, which is my main responsibility at Blockstack, happens in the develop branch of the Blockstack core repo in the Blockstack organization. We're also documenting the design of the system as we build it, and you can see that under the SIPs folder, SIP being an acronym for Stacks Improvement Proposal. And everything's happening there. We hope to have it out sometime in Q1 of next year. And main project website is blockstack.org. Our explorer is explorer.blockstack.org. And hope to see you online.
Awesome, man. Awesome. Again, Jude, thank you so much, man. Thank you.